let's present an analogy that will help us understand the seismic example. We'll use different situation, and I think it will be transparent to then apply the seismic formulas that we saw before in previous panel. This is the situation. We have a race between the hare and the tortoise, the rabbit and the turtle. They both leave Vancouver in cars, effectively. The rabbit has a fast car that goes at 200 kilometers per hour. The tortoise has a slow car that goes half that speed, 100 kilometers per hour. They both leave Vancouver at the same time, and they drive at a constant speed. They're always driving at these two speeds. They don't change. So we don't know when they leave. We're waiting in Seattle, and we just can see when the respective cars arrive. The fast car, the rabbit car, arrives in Seattle at noon. The slow car, the tortoise car, arrives 1 hour later. It's slower. The question is, how far away is Vancouver from Seattle? Let's check it out. Okay, in principle, we don't know that. We're going to try to find out from this data. All right, so the distance, which we don't know, is equal to the velocity of the fast car, Vf, times the time it takes for the fast car. The only thing I know about this is Vf, fast car, 200 kilometers per hour. So in principle, I can solve for Tf. An unknown distance, which will be obviously in kilometers, divided by the speed of the car, which is 200 kilometers per hour. So this will be in hours. But I don't know D, and I don't know when the cars left. I'm clocking their respective arrivals, them having left Vancouver at the same time and arriving at Seattle at different times, noon and 1 o'clock. The same for the slow car. D equals V slow times slow. So we can solve. The only thing I know in this equation is V slow, which is 100. So that's D over 100. Now what do I do? Well, I know the time difference between these two arrivals. It's 1 hour. But the time difference is the slow time minus the fast time. So I subtract these two. So just go here. Ts minus Tp, which I know. That's 1 hour, is equal to D divided by 100 minus D divided by 200. Well, we can do this, right? That's an easy fraction to subtract. This is equal to, well, how many 100s are there in a 200? There's 2 of those. So this is equal to D over 200. That's in kilometers per hour. The time difference is 1 hour. So if I multiply both sides by 200, I get 1 hour is equal to D over 200. Now, kilometers per hour. If I multiply by 200, I get 200 kilometers per hour for 1 hour is a distance of 200 kilometers, the distance from Vancouver to Seattle. You can see the analogy clearly. The fast car is Vp. The slow car is Vs. The distance D is not the distance from Vancouver to Seattle, but the distance from dPRK to MDJ. The only thing we did is do the algebra where we factored out the D, but this is how it works, and that's what you can do. And that's the analogy between the fast car, the rabbit car, and the turtle car, the slow car, and the arrivals of seismic waves from a given source to a given receiver.